All right, hey guys, and welcome to our second factoring lesson on how to factor a simple trinomial. Now, before starting this video lesson, you were supposed to complete the previous page, which is this one I have up right now, on factoring a simple trinomial. It's a bit of an investigation to help guide you through how we're getting these answers so that you can see for yourself how it works and maybe understand it a little better. So if you haven't done this yet, make sure you stop the video, please, and go back and try this page first. If you're done already, here we go then. We're going to go through this real quick. So for these here, you were provided with two binomials and asked to multiply them together. So just foiling them out. So x times x and so on, and then multiplying your 3 in, collect your like terms and your final answer. So double check really quickly with me your final answers, see that you've got the right ones. And then you were asked to copy them into the table so we could see what kind of relationship or pattern is happening here. So down in the table, your m and your n values are just the two numbers that were in each bracket in the original question. So you've copied those out, hopefully, making sure you have negatives where appropriate. And then on the right-hand side, your final answer for each of those questions from above, you're to put in these boxes here. And b is the number in front of your x, so you'll notice it might be a negative, or if you don't see it, remember it's always a 1, it's not 0, it does exist. And then c is your constant at the end. So you're asked to look at the relationship between those original two numbers, mn, and the b value. So 3 and 2, and my b value is 5. Negative 4 and negative 1, and my b value is negative 5. 4 and negative 3, my b value is positive 1. So if you look over these sets of numbers here, you should hopefully recognize that if you add your m and n values together, b is the sum of those. So 3 plus 2 is 5, negative 2 plus 5, positive 3. So when we FOIL this guy out, that middle number is always the sum of the two original numbers that we started with here. And for the second one, what's the relationship between mn and c? So same thing, looking at these two original numbers and what number we had at the end there, we always had the product of your mn. 3 times 2 is 6. Negative 4 times negative 1 is 4. Negative 2 times positive 5 is negative 10. And this really does make sense if we go back even just to one of these and look at our work. For this one here, our x's gave us that x squared component. Our x times 2 and our x times 3 are giving us these guys. And then what we did before we get to our final step is we just added them together. So because both of these x's have 1s in front, we just end up getting those same two numbers, a 3x and a 2x, and then we add them together when we collect like terms, and we've got that 5. The last piece that we get is always from multiplying those two numbers together, that last piece when we're foiling, and we've got that plus 6 there. And you can see that with all of these questions. The negative 4 times x, we had that negative 4. The negative 1 times x, we got the negative 1x. Collect your like terms, we add, there he is. To get that last term, it was always that multiplying of the last when we're foiling. All right, so moving along here, what we're going to be looking at today is another type of factoring called simple trinomial factoring. And basically, this is the reversal of foiling when we're looking at simple trinomials. There's something special about a simple trinomial, and that is that the number in front of your x squared is always a 1. So that's an important piece to recognize when we're looking at these. Eventually we're going to be looking at some that have different numbers in front, and they're a little trickier. So the rule here is if you have a simple trinomial, it can be written as x plus m times x minus n. And to figure out those two numbers, we know that m and n have to add to the middle term, and m and n have to multiply to the last term. So let's look at an example, because this is the best way to figure this stuff out. If I asked you to factor x squared plus x minus 6, first thing, this is a trinomial. Trinomial, tri, just means it has 3 terms, so 1, 2, 3 terms. We've got an x squared, we've got our x, and we have our constant. The number in front of the x squared is a 1, and that's what makes it simple. All right? So what we need to look at here is what are the b and c values. So the a is 1, which is what we need. The b value here is 1, the number in front of the x, and the c value is negative 6. So I know that I need two numbers that multiply to negative 6 and add to positive 1. To figure out those numbers, we always want to start with that product, the one that multiplies, because there's a limited number of factors that we could have when we're looking for integer values. Things that add up to 1, there are millions of options, okay? Unlimited options. For example, 2 and negative 1, 3 and negative 2, 4 and negative 3, and so on. This goes on forever. So we don't have a limited supply. These guys we've got a limited supply of. So to find the factors of negative 6, I start by just finding the factors of 6. So 1 times 6, 2 times 3. Since it's negative, one of my two numbers has to be negative. Now you'll notice I jotted this down twice just for a visual for you, because either the 1 can be negative or the 6 can be negative. 2 times 3, you could have a negative 2 times 3 to get negative 6, or the opposite. So the first thing you want to do is think about the factors. Now you might not have to write out all of the factor combinations. You might find your answer before you list them all, and that's great. But if you're having trouble, go through and list them all. So these all multiply to negative 6. Next question, which one of those adds to give me that number in the middle, adds to a positive 1? So negative 1 and 6, that gives me 5, so that's not right. Negative 2 and 3, oh, that's the 1. Adds to positive 1. And as soon as you find it, that's it. That is the number. These guys aren't going to work. So to write the final answer, you're going to open up two brackets, and each bracket in a simple trinomial factor has to start with x, because as we know from all the previous FOIL examples, x times x is what gives us that x squared. The other two pieces of the brackets are your m and your n. So in this case, one of my letters, or one of my variables here is negative 2, and the other one is positive 3. It doesn't matter which one goes where. I could put x plus 3 and then x minus 2, that's fine. But that's all there is to it. So the toughest piece is finding those two magic numbers to make it work. So down here are some more examples for us to work through. I am going to work through ACE with you. If you feel like you think you can start this on your own already, feel free to pause it now and give them all a shot. If you want to go over a couple more with me, then stick around for a minute. So for this first one, it is a simple trinomial. There's a 1 in front of the x squared, 3 terms. I see my x squared term, my x term, my constant. So I need to find two numbers that multiply to 27 and add to positive 12. So there's 1 times 27, 2 won't work, 3 times 9, 4, 5, and 6 don't work, 7, 8 don't work, so those are the only factors I've got. Now in this case, they have to add to positive 12. Hopefully that's what's pretty straightforward to see. Keeping in mind, there are always two potential options. Another potential thing you might see is where they're both negative, they would also multiply to a positive 27. Now that's not needed here, negative 3 and negative 9, because they're adding to a positive 12, but those are other possible factors in this scenario. So once we have our m and n, open up your two sets of brackets. Because it's simple, each bracket starts with an x, and then we have a positive 3 and a positive 9. If you FOILed that out to do a check, you would see that they're exactly the same. Next one down, I need to find two numbers that multiply to negative 12 and add to positive 1. So 1 times 12, 2 times 6, 3 times 4. One of those two numbers has to be negative in order to give me a negative 12. So if you want to jot it out so you can actually visually see all 6 options, go ahead. If you don't need to, you don't need to. It needs to add to a positive 1. For me, that tells me if I have one bigger number, one smaller number, the bigger number's got to be the positive one. One's negative, one's positive. So the bigger one's going to have to be positive. So in this case, negative 3 times 4 is negative 12. Negative 3 plus 4 is positive 1. Those are your two factors. So we go x minus 3 and x plus 4. Voila! Last one, in purple for a change. So for this one here, you want to start factoring it. You're all excited. It's not a simple trinomial. See this guy right here? It's not a 1. That value in front of the x squared must be a 1. So the nice thing here is we're going to be able to common factor it out. So this is a multi-step factoring problem for you. So the first thing you're going to need to do, common factor out your 3. That leaves you with x squared dividing out the 3, if you remember common factoring from yesterday. So 18 divided by 3, 27 divided by 3, like that. Then when you look in the bracket, what's left over is now a simple trinomial. So I need to find two numbers that multiply to 9 rather, and add to negative 6. So 1 times 9 or 3 times 3. 1 plus 9 is 10, 3 plus 3 is 6. Neither of them add to negative 6. But remember, like what I mentioned above, if you want to get a positive number when you multiply, they could both be negative. Negative 1 times negative 9 also gives you positive, and negative 3 times negative 3 also gives you positive. So for this one here, our two numbers are going to be negative 3 and negative 3. So the 3 is still sitting out front. Don't forget about your greatest common factor that we pulled out. And then when you factor this simple trinomial, we've got x minus 3 times x minus 3. Now this can actually go one step further. Because these brackets are the same, to fully simplify this, best form, we can actually write it as if it's squared. And we saw ones like this earlier when we did FOIL, that you would take this expression and you write it out twice. So to fully simplify it, put it with a squared. So what I want you to do now, if you haven't yet, is pause the video, try B, D, and F, and then pop back in here to check. All right, welcome back to checking your answers here. So for the first one, multiply to 12, add to negative 8. Those two numbers would be negative 2, negative 6. Negative 5 and 2 for this one. And for the final one, you have to common factor out that 2 first. What's left in the bracket is now a simple trinomial, and then you can continue and factor that. So one last thing I want to show you, it's not on your sheet here, but it's just a little mini sort of cheat box if you need help coming up with the factors, especially if you have trouble knowing if you need positives or negatives and whatnot. This little box here, you might want to jot it down somewhere, but it's going to help you figure out what your m and n values are going to look like. So if you're multiplying to a positive and you're adding to a positive, both numbers would then be positive. So an example of that would be like this one here, A. We're multiplying to a positive and we're adding to a positive. Both of my values, m and n, are positive. Then if you are multiplying to a positive but adding to a negative number, when that happens, both your m and n are going to be negative. So an example there would be like B here. You're multiplying to a positive but adding to a negative, and you can see both numbers in the brackets here are negative. And for the last two, if you're multiplying to a negative, one of your two numbers has to be negative. One will be negative, one will be positive. So for both of these, you have one negative, one positive number. So what's helpful to know is if they're multiplying to a negative but adding to a positive, the positive number has to be the bigger one. And the reverse happens if you're multiplying to a negative and adding to a negative, that means the negative number is going to be the bigger of the two numbers. So you can see that happening in some of our examples here. This one multiplies to a negative, so one's negative, one's positive, but the negative is the bigger. 5 is bigger than 2. As well over here, multiplying to a negative, adding to a positive. So one's negative, one's positive, but notice the positive 4 is bigger than the negative 3. So you might want to jot this down. It might help you coming up with those factors, especially if you struggle with those integers. So that's it for today. Holy moly, we're done. Whew.